Good evening, I am Mr. Ish. You are joining me for this video. Is the parabola vertex differentiable? That is, can you determine a derivative at the vertex of a parabola? That is the question for this video. We have as our model equation this right here, y squared plus 4y minus 8x equals 0. Judging by this appearance, you know it's going to be very likely a right-facing parabola. We'll do the major conversation over here with regards to this. You have to determine, not necessarily, but it would be good to determine a vertex so we can graph it out so we see what we are doing. And you would do completing the square. Y squared plus 4y plus 4 is equal to 8x plus 4. You know, completing the square is not a difficult technique. You get a y plus 2 whole square is equal to 8 into x plus 1 over 2. If you were to open all of this expanded, you should end up back over there. If you convert it into that form, you're looking at y minus 2 whole square is equal to 8 into x minus 1 over 2. And that tells you the vertex over here is this, minus 1 over 2, comma, minus 2. It's good to determine a p-value and a focal point, so why not? When you're looking at this 8, it's really a 4 times 2. So that tells you your p-value is a 2. You're looking at a right-facing parabola with a focal point which will be 2 units away from the vertex. X value of the vertex shifted 2 units will be the focal point, and that makes it 3 over 2 comma minus 2. If you put a x value of a 0, you can get two y values. Y squared plus 4y is equal to 0. Y into y plus 4 is equal to 0, and you get y is equal to 0 comma minus 4. These are your y-intercepts, and it tells you there's a good value here at the origin. If you were to graph it out, you're looking at a minus 1 over 2 comma minus 2. We're not too accurate over here, and a focal point of 3 over 2 comma minus 2. We know we have a line of axis here of y equals minus 2. We have a y-intercept here of 0 comma minus 4 and a 0 comma 0 origin. If you graph it out, you're looking at something like this. Not 100% accurate in terms of my drawing, but this is 100% in terms of the points. Focal point 3 over 2 comma minus 2 right over here. Is this specific point right here differentiable? That is, if you did a derivative over there, try to determine an equation of a tangent line, could you do a derivative here at this specific point? Let's find out. Since we have an equation here, y squared plus 4y minus 8x, you couldn't cleanly solve this equation such that you have y equals format, because you couldn't. You'd have to do implicit differentiation over here, so let's do it. We know the format for implicit differentiation. Let's expedite through it. You're looking at this equation. I just took the x component on the other side. When you do everything over here, you're always solving for dy over dx, which is synonymous with y prime derivative with respect to y. We're solving for that. When you do the derivative of y squared, you get a 2y dy over dx. When you do the derivative of 4y, you just get a 4 with a dy over dx. The derivative of 8x is just an 8. You're solving for dy over dx. You isolate and take it on the other side, you'll get 8 over 2y plus 4. And we're seeing if this point, the vertex, the parabola vertex, is differentiable or not. We have values right here. This value feeds in right over here. But there's no x component here, but that's fine. You have a y component, you can put it over here. You have 8 over 2 times minus 2 plus 4. When you do this, you get an 8 over 0. You know that's undefined, you can't do it. Why is this undefined and why couldn't you do it? Why is this specific point here not differentiable? Well, it would be the same case if it was a left-facing parabola. For right and left-facing parabolas, it would not be differentiable, because when you're trying to create a tangent line over here, you know the tangent line is going to be a vertical line. Vertical lines have x equals a format. And if someone told you to find the slope of a vertical line, you know you're doing change in y over change in x, which is y2 minus y1 divided by x2 minus x1. Well, you do certainly have a change in y component because the line is up and down, but you have no change in x component because there's no horizontal deviation of this line. You always end up getting a change in y over a 0, which you know is undefined. Hence, you cannot do a derivative at this specific point of the parabola because of the presence of vertical tangent lines. When you have vertical tangent lines, you know you cannot do slope determination. So that's the case for right and left parabolas. Even though the example is for a right-facing parabola, the same everything applies for a left-facing parabola. However, if the equation were presented here for an up and down facing parabola, the story is quite different. Generally, we're looking here in precalculus at two forms of parabolas. Either they point up or down, or they point right and left. We're not doing any type of rotational conics where they're pointing at an angle. But given these two forms, I've said right and left facing parabolas are not differentiable at the vertex because of the presence of vertical tangent lines that arise. Vertical tangent lines are a no-no for derivative determination because the slope is always undefined. But however, for up and down facing parabola, you have the presence here of a horizontal tangent line. They clearly form over here, and that's good. And that there's nothing wrong with that. Horizontal tangent lines will have a slope of 0, therefore their line equations will always be y equals b, whatever it might be, y equals b here, and y equals minus b over here. Or even if your parabola was here at the vertex, either an up or a down facing parabola, here your x-axis would be your tangent line, and here it's y equals 0. So the short answer to this question here, the differentiability of a parabola vertex is for right and left facing parabolas, you cannot do derivative determination of the parabola vertex because of the presence of vertical tangent lines. But for up and down facing parabolas, you certainly can do it because you have legitimate tangent lines forming which are horizontal. They have a slope of 0, and you can easily calculate a equation of a tangent line. It just happens to follow the y equals b or minus b or y equals 0 format, and these instances are good. And that would be it for this video. I hope you enjoyed this video. Stay tuned for many more interesting videos. Thank you for watching. Have a nice day.